You know, it's kind of funny. We hear all this buzz about dApps changing the world, but then you talk to the folks actually building them.
Yeah.
And it sounds less like a revolution, more like trying to solve a puzzle in the dark. Super complex and, lots of brick
Oh,
walls.
absolutely. I hear that all the time. The potential's massive, sure, but the actual doing it on a lot of platforms, it can really kill creativity.
Mm-hmm.
Steep learning curves,
Yeah.
feeling boxed in.
Right. Which is exactly why we're digging in today. We've been looking through the intro docs for the Constellation Network.
Ah, Constellation.
Yeah, and they talk about this toolkit, the Euclid SDK, says it's built specifically to tackle those headaches.
Exactly. And for you, the learner, this is really about getting your head around a different way to build these decentralized apps, maybe a more flexible, more efficient way.
Yeah.
Without needing, a deep dive into crypto theory beforehand.
So our mission today.
Let's pull out the key ideas behind Euclid, why it exists, what makes its approach different, and maybe why it unlocks things that are, let's say, harder on the big established platforms.
Yeah. Okay, let's do it. So the docs, they don't really pull any punches about the problems, do they? They mention the challenging task, the steep learning curve, but also this idea that many popular platforms are basically closed systems. What does that actually mean if you're a developer trying to build something new?
Right. So think about those systems. And yeah, the docs call out Ethereum, Solana, Hedera specifically.
Okay.
They're kind of like walled gardens. They give you a set of tools, rules, functionalities, and that's it. It's stable, it's tested, which is good in some ways. But you sacrifice flexibility. Big time. You might have a great idea, but if it requires a type of logic the platform wasn't designed for, or needs to handle data in a way it doesn't allow, well, you're stuck.
Like trying to cook a gourmet meal with only a microwave and a spork.
Huh. Yeah, something like that. You're locked into their menu, their way of doing things.
Gotcha. And this is where Euclid steps in, offering, as they say, a more flexible approach. How flexible are we talking? What's the core difference?
Well, the really big deal with Euclid, its whole philosophy, seems to be empowering developers to, get under the hood.
Right.
It's not just about using the tools they give you.
Okay.
It lets you bring in common libraries you already know.
Yeah.
And actually customize the internal workings of your own specific network built on Constellation. That level of control, that's just fundamentally different from the take it or leave it model.
So complete customization of network behavior, let's make that real.
Yeah.
What could a developer do with that kind of power that they maybe couldn't do easily elsewhere?
Okay, good question. Imagine, say you're building a secure voting dApp.
Right.
With Euclid, you could potentially design your own consensus mechanism. One may be specifically tuned for election integrity, maybe with fraud detection logic baked right in, something that's not standard on generic platforms. Or think about scientific research apps dealing with really complex specialized data. You could define totally custom data types and the exact validation rules needed for that specific data. You're not limited to just simple numbers or strings. That granular control, it just opens doors for way more tailored, maybe more efficient applications.
Okay, that makes sense. Now, the docs also mention Constellation's own architecture. It's scalable, yes, but also potentially complex for local development because it uses microservices. How does Euclid help smooth that out for developers?
Yeah, that's a really practical point. Constellation's design with all these little services working together is great for scale and resilience on the live network. But for one developer trying to juggle all those pieces just to test something locally, that could be a real pain.
I can imagine.
So the Euclid SDK basically gives you a set of powerful tools to manage all that complexity locally. It simplifies setting up, running, and connecting these services on your own machine. Think of it like a really good development environment or a control panel specifically for Constellation's architecture.
Ah, okay. So it tames the beast for local work.
Pretty much. It lets developers focus on their app's logic, not wrestle with infrastructure setup just to get started. Makes building and testing way smoother before you even think about deploying.
Right. Now, this term metagraph keeps popping up. What is a metagraph in Constellation's world, and how does Euclid make building one easier?
Okay, so a metagraph. Think of it as your own custom blockchain, or maybe a state channel network built on top of the main Constellation network, the hypergraph. It's tailored for a specific application or business need.
A custom network on the net.
Exactly. And building one involves this process called tessellation. Euclid helps by providing what they call composable patterns. These are like pre-made code blocks, logical structures that handle a lot of the common foundational stuff you need for any metagraph.
So it abstracts away the boilerplate.
Precisely. It gets rid of a ton of repetitive low-level coding. But, and this is key, they're just starting points. You can still inject all your custom logic, tailor it exactly how you need. So simplifying the local dev helps you build these microservices, which then makes it easier to assemble them into these bigger custom networks or metagraphs.
Okay, so building blocks are provided, but you can still carve them up or add your own unique Lego bricks. What's the payoff for the developer in their day-to-day workflow?
Speed
Yeah.
and focus. By taking care of that foundational network stuff, Euclid lets developers spend their brain power on the actual business logic, the unique thing their dApp does.
The secret sauce.
Yeah. They can get from an idea to a working version much, much faster. They're not constantly battling the platform's limitations or getting bogged down in complex setup that you might find in those more rigid closed systems. Plus, iterating, making changes much quicker.
Makes sense. The docs also really emphasize that the SDK is extensible and has a modular design. Why are those aspects important down the road?
Well, extensible means it's built to grow, right? Add new features, adapt to new tech, support use cases nobody's even thought of yet. It's future-proofing.
Unmodular.
Modularity is about flexibility and reuse. You can pick and choose the components you need. Maybe you need currency features, but not identity management, for instance. You pull in just a currency module.
Ah, like a toolkit with interchangeable parts.
Exactly. And those parts, those modules, can potentially be reused across different applications. This encourages a whole ecosystem of dApps built with Euclid that could potentially work together seamlessly on the main Constellation network, the hypergraph, because they're built from compatible modular pieces. Developers choose what they need.
Right, fostering interoperability. And then they mention these micro frameworks coming into Euclid. What role do they play?
Think of microframeworks as even more specialized toolkits within Euclid. Each one focuses on a specific complex job. Like instead of building a whole digital currency system from the ground up.
Which sounds hard.
Yeah, incredibly complex. Instead, you could use a dedicated framework that handles most of the heavy lifting for currency creation, management, transactions, etc., according to best practices.
And we see the first one is out already, the currency framework. What does that let you do specifically?
Correct. The currency framework is the first example. It gives developers a standard, efficient way to create and manage their own high-speed digital currencies. These currencies follow Constellation's own metagraph token standard, so it handles all the mechanics, minting, sending, receiving tokens.
Wow, okay. So literally, someone with the right dev skills could spin up their own digital currency using this. That's quite something.
It's a pretty powerful tool, yeah. And while it's the only one released now, the docs make it clear they plan more. Frameworks for other complex tasks, simplifying different kinds of dApp development down the line.
So the big picture, the philosophy here, it seems to be about giving you power, but also making it manageable. Easy starting points with the frameworks, but the option to go deep and customize if you need to.
That nails it. Each framework aims to hide the low-level complexity of Constellation, lets you work higher up the stack. But crucially, that abstraction doesn't lock you out. The power to customize, to extend, to really build your specific thing that remains fundamental to Euclid. It's about giving developers strong tools and unleashing their creativity.
And for anyone listening whose interest is piqued, thinking, okay, I want to try this, the docs actually point the way forward, don't they?
Yep, they explicitly mention the Quick Start Guide. That's flagged as the go-to next step if you want to roll up your sleeves and start playing with the Euclid SDK yourself.
Okay, so let's wrap this part up. We've seen how the Euclid SDK aims to solve those common dApp development frustrations, the complexity, the limitations of closed systems like Ethereum or Solana. It offers more flexibility, deep customization, and simplifies working with Constellation's scalable but potentially complex microservice architecture.
Right, using powerful local tools and these modular components.
And it provides these domain-specific micro-frameworks, starting with the currency framework, to speed things up even more, but always keeping that door open for deep customization.
That sums it up really well. For you, the learner, the core idea is that Euclid represents a different way of thinking about blockchain development. It's leaning into openness, giving developers serious control, but trying not to overwhelm them.
Yeah, it suggests this combination of flexibility and speed could lead to maybe more diverse, more innovative dApps down the track.
That's the hope, I think.
And it really does make you wonder, doesn't it? If you give developers this kind of fundamental control, not just building on the rails, but actually shaping the rails themselves, what totally new kinds of dApps could emerge. What problems that seem inherent to blockchain today might just disappear when you have that level of freedom to tailor the core mechanics. Definitely something to keep an eye on.